I'm also joined by my colleagues, James. He is also a customer success manager, Joe Miller, our senior technical specialist on the RTDS side, Parivat, our software development specialist on the RTDS, and Jeff Sewell, senior product manager on the RTDS system. Before we start, there are some housekeeping items. Please note that we will be recording today's session. We will share the recording, presentation slides, and other relevant materials with you as soon as possible. If you want to raise a question, please use the Microsoft Teams chat function. We'll answer your question at the end of this session. During the presentation, all participants are muted. For the Q&A session at the end of this webinar, you have the possibility to unmute yourself. So we are now moving to the agenda slide. Today, we will give you an update on the real-time data delivery strategy, inform you on the RTDS and the product updates and enhancements. We'll give you an outlook on the RTDS roadmap, and we will have a live demo on one of the new RTDS features. At the end of this webinar, there will be a survey link. It will be great if you can share your feedback. Probably most of you had joined our customer advisory forum last Wednesday. In this session, we are talking about our new real-time data delivery strategy and the migration from bandwidth optimized to Refinitiv real-time optimized. For those of you who could not take part, my colleague James will give you a short summary now. I will hand over to James now.
Thank you, Christian. Hope you can all hear me perfectly well. Okay, yeah, so you should be aware that typically full tick and bandwidth optimized data is distributed to customers typically privately via edge devices, which are physical devices sat in comms rooms and so on, and they're typically there in pairs, very often in different locations. The update really is that those which are only for bandwidth optimized data on our BON network, for those edges, we are actually going to be migrating those to our real-time optimized connection, which means those edges will go away. This is in line with our strategy for our updated resilient service. Typically these will have private connectivity in place, and that will remain. It will just be an update, sort of new credentials which will be configured into the RTDS components. There'll be no difference in the quality of service, and obviously there'll be an option to kind of review how those connections are managed, private, directly over the internet, and so on, size. The one caveat here though is that it will require an update to the software to the latest version, so we can actually run that, put that configuration in. Yeah, and obviously there are some additional benefits of more flexible DR failover options, and of course you'll have a little bit more room in your site with those edges being removed. Yeah, and of course one of the options which we can give you is that if you are interested in us actually hosting the RTDS system in the cloud, that's something that we can do as well. So it might give you an opportunity to think in those terms. Okay, that's just about the full summary, I believe. Back to you.
Thank you, James. While I shared the recorded session to the BON to real-time optimized webinar link, you can easily register by yourself and see the have a review on this webinar. I will hand over now to Jeff. He will give you an overview on the latest RTDS product updates and enhancements.
Thank you, Christian, and good day, everyone. Thank you for joining us for another real-time distribution system and DACS roadmap review. The real-time distribution system roadmap includes a list of our large enhancements, but today we're only going to focus on those that were included in our 3.5.3 release at the beginning of October and our large enhancements that will be delivered in our 3.5.4 release at the end of Q4. We only list the large enhancements on the roadmap, but we also include a number of small enhancements and a number of bug fixes with every new release. The What's New doc includes a list of all the enhancements for each release and is available to download on My Refinitiv, and Christian will provide you a link to that doc in the chat window. What you'll see in this doc is that we continue to invest in the real-time distribution system and DACS to add valuable enhancements. Many of these enhancements requests come from customers, and this is part of every release that goes out the door. Many of you know we've been running ADS POP at Amazon AWS, which is our cloud infrastructure for real-time optimized data feeds since the fourth quarter of 2018. So it's basically been a full 3 years now. And over the last couple of years, we've heard from our customers that they want more than one choice for a cloud service provider. So as of this past June, we provide customers with Category A support for the real-time connector at all three major service cloud providers, so at Amazon, Google, and Azure. So this means we met our customer requests and our strategic goal to be cloud agnostic. However, being able to access data from a cloud deployment is great, but what about entitlements for compliance and cost control? That takes us to the first line here on the roadmap. You'll see at the beginning of October, we extended Category A support for the ADS POP or real-time connector running at Microsoft Azure. And this also includes DACS, which I'll show you when we get to the DACS roadmap. We offered the same for Amazon AWS at the end of June, and we'll offer the same for Google GCP at the end of December. Now, the point I want to make here is this is more than just providing real-time data, obviously with including DACS basically. So with this predefined off-the-shelf real-time connector and DACS deployment, we're able to provide you a standard cost-effective deployment that will address the requirements for a majority of our customers that you can manage yourselves and that is supported by us at our global help desks. So if there's something more bespoke you need, our professional services group has built a number of custom deployments for those that require bespoke solution that where basically this one size fits many model doesn't work, right? So we can address different requirements, but again, the point with the predefined off-the-shelf deployment, it's cost effective and it'll address many of the use cases that we have seen and had requested for. All right. The second line item on the roadmap is cascaded persistent mounts, which is a great new resiliency feature that will provide quicker recovery in the event of a failover with less chance of data loss, which results in basically higher data integrity. And I'm going to turn this over to Parava, who's one of our lead developers, and he's going to cover this new enhancement and show you a demo of how this feature works. Over to you, Parava. Parava? Maybe not, huh? Okay, maybe we'll come back. Maybe we'll come back to Parava then. All right, let's go ahead and switch up. Keep on going. We'll get up to slide 10 then. Yeah. Okay. So at the beginning of at the beginning of October, actually now we're in the middle row on the screen, you'll see we delivered Red Hat 8 support for the real-time connector. Customers were asking for this enhancement, that was scheduled for December, but we were able to fast track it and deliver it earlier in the 3.5 release at the beginning of October. So this means now that we offer real-time connector binaries for Red Hat 8 with Category A support. And a couple of those benefits are improved performance and enhanced security for running with Red Hat 8 as OS, right? We also added another enhancement here in Q3 that was not previously on the roadmap. Back in June of 2019, we introduced a threading model on the real-time connector in ADS POP, which leverages item threads to take advantage of the multi-core processor servers to increase performance and throughput. All of our performance metrics are well documented, thanks to Mahesh, and available to download on my Refinitiv. Joe, who's the development manager out in Oak Brook, is going to explain to you how enabling channel threads will allow us to better scale the item threads on the real-time connector and increase throughput. So over to you, Joe.
Thanks, Jeff. Next slide, please. Thanks. So those of you familiar, we added channel thread support in ADH back in 3.2.3. We had a little bit different architecture between ADH and the ADS POP at the time, but I want to kind of go through what our evolution has been with the ADS POP RTCs to really kind of show you guys, why we added channel thread support in 3.5.3. So the first slide here is single thread. All right, those of you familiar all the way back to Triarch, right? This is how it first came out, right? So the main thread handles everything, handles the multiple connections to the publisher, handles the multiple connections to the subscriber, and obviously, everything's done within the main thread. So limited scalability here, and the next evolution, next slide, please. That we added was writer threads, right? So again, this is an ADS LAN, ADS POP, and obviously the RTC. So we really want to achieve that market leading fan out that the ADS is known for. And this is how we achieved it, right? We're able to scale out the writer threads now. The writer threads do all the communication with the subscribers and consumers, buffer management, all the data conversion, compression, and encryption is all done in the writer threads. The main thread's still responsible for talking to the publisher. All the caching, load balancing, MQS is still done in the main thread. So obviously you can see that where our next bottleneck became. We want to be able to scale that caching layer out. So the next evolution that we had was, the next slide, please, was item threads. And these are all options that are available today. So given what your throughput requirements are, given what your hardware requirements are, these are all options that you guys can enable today. Obviously, the next evolution was in the item threads. That's been there for quite a long time, the ADS POP and the RTCs, obviously now. So what this now allows you to do is scale off the caching layer, right? So all the caching, load balancing allows you to scale that off. The main thread still makes the connection up to the publisher for the source directory information. Any synchronization that we have to do across the item threads is really controlled from the main thread. There's still the writer threads there to get your fan out, and all the responsibility then can scale out. We left it at each item thread makes a connection to the publisher. So each item thread is responsible for its reading. It's all the I/O is done off the item thread. This scales really well. The only issue with this is as you add connections, as you rehash items across multiple channels, you're going to obviously decrease your packing rates, right? So that decrease in packing rates increases your packet rates down to the item threads. And obviously your scalability then gets hindered a little bit with those additional packet rates. So that's where we looked at the ADH, what we had with the channel threads, and we want to make that available in 3.5.3. So the next slide, please. So the next slide, anyone familiar with the ADH channel threads, high level architecture looks really identical, right? So then you have your main threads still connecting up to the publishers, but now what you can do is your item threads can hide behind the channel threads, right? So each channel thread supports n number of item threads. So you can scale up that caching layer. You can keep your channel threads the same depending on the CPU levels of your channel threads. Your channel threads do all the communication to the publishers. They do all the I/O events, and then they hand that off to the caching layer. Your item threads still do the caching, do the MQS, and then you still have your writer threads. So with this, you can scale your item thread layer again, and you can leave it all your channel thread, your number of connections the same to your upstream publisher ADS, right? So the ADS publisher sees no difference as you can scale up those item threads as you have available cores. Once you start running into channel thread CPU issues, you can scale out your channel threads as well. So it really allows that next level of scalability to the RTC, and really allows you to keep the number of TCP connections the same. So Those of you guys going into RTO where you have that 5 connection limitation and you really need to scale out those item threads, this is a great way to do it, right? You can manage 2 or 3 connections using channel threads, and then gives you the ability to scale out those item threads underneath. So one quick note, we really did mostly focus on qualification in 353 for the channel threads. So we know warm standby right now isn't supported. Warm standby is not supported out of RTO yet. So our plan is next year when we can get that enabled out of RTO, we can get that enabled inside the RTC for channel threads as well. So any questions, drop them in the chat or send me an email, and I'm happy to answer anything you guys have. So this is all available in 353, and I think that's all I have. So back to you, Jeff.
Okay, we have one slide from your side.
Yeah, thanks, Christian. One quick plug for 353, another nice enhancement we did, I think, the monitored screens. So this is available in ADHMon, ADSMon. If we ever do another WPG release, which I'm sure we will at some point, it's going to be available in WPGMon as well. And of course, the RTCMon. So on the left is your top output, right? So you guys know how we do that. We name the threads so you can see in the top output. For channel threads, it's going to be just like ADH. So it's going to be rtc.ct for all your channel thread. And on the right is the new screen that we have in 353. So before we didn't have all the CPU binding stats in shared memory. And even the ones we did, we kind of had them sort of spread all over the place there. So what we did is we consolidated everything into one location for you guys. And then you can pull that one class, for example, if you're using REST or obviously the monitor. You can go to one class, one location, and get all your thread binding information there. So prime topology is there, whether it's true or false. And then any thread that's available will be here. The only thing that you guys are familiar with RTO or TSA, we use Reactor to get access to those services. The Reactor does have a thread. So right now that's not currently bindable, but we know we have an enhancement request in to get that bindable through the RT-SDK guys, but we don't display that there, but that'll be a future enhancement. So, but everything else is there. So we had a DNS thread. Obviously, once you guys start talking ADH, ADS, all the RCP threads will be available here as well. So I think a nice enhancement for you guys in 353 as well. Thanks, Christian.
Thank you, Joe. So we have now 2 possibilities. Jeff, will you go forward, or should we hand over to Parivat?
Is Parivat available?
Yes, he is. So, and yeah, I will go back to the slide number 8 now. Stop sharing for a moment, and we share slide number 7 now. So
yeah, so let me just give the intro again. So basically on the roadmap for this release that we just had earlier this month was cascaded persistent mounts. And as I said, it's a great new feature for resiliency to provide quicker recovery in event of a failover from a primary to secondary server with less chance of data loss, right? So the benefit here is higher data integrity, and Parivat, again, who's the lead developer, is going to cover this new enhancement and give you a demo of how this feature works. So over to you now, Parivat. Hopefully.
Thanks, Jeff.
All right, good.
Hi, everyone. My name is Parivat Pongpesach, RTDS software developer. Today, I'm going to talk about the cascaded persistent mount feature, which is a new feature we introduced in RTDS version 353. So the overview, can you go to the next slide?
yes.
Thank you. Yeah, the persistent mount feature basically offers seamless, quicker item stream recovery after the session has been disconnected and reconnected. The upstream ADS and the consumer app, the cascaded component periodically synchronize the inbound and outbound sequence numbers in the generic message sent over the login stream. And during the disconnection, the mount persists in the upstream component and the server stay in the cascaded component. Right? The persistent mount maintain the watch list for configurable time period. So all the watch list is maintained in the upstream ADS so we won't lose anything. And if we receive any update for those items during disconnected, we put those items into the overflow queue, right, to mark those items as an unsynced item. So we know that once we reconnect, we have to send an unsolicited refresh for each item stream in the overflow queue. And then all the item stream can resume operational. And there are a couple caveats. The first one is the persistent mount logic is done between both sides, upstream and cascaded component. So that means the upstream component right now, it has to be ADS, and then that downstream can be either RTC or ADH. And to take advantage of the persistent mount feature, we have to make sure that the cascaded component reconnect back to the same ADS instance. So in some deployment where we use non-sticky load balancer, we have to make sure that the cascaded component connect back to the same ADS instance. And let's go over into the details a little bit. So on sunny day, as we can see, we have upstream ADS right here, and then cascaded component RTC. So periodically, we send generic messages in and out on the login stream to make sure that to keep track of the last message that has been sent and received. And then during disconnected, right, the mount persists in the upstream ADS. We can see that the mount is still there. And anything that going into those items, we're gonna put it into the overflow queue. And once the connection is reconnected, we send unsolicited refresh for each item in the overflow queue. And then our data stream will resume operational as usual. In terms of configurations, in the upstream ADS, we just configure persistent recovery time. So basically, how long we want to persist the mount in the upstream component. By default, it's 10 minutes. And on the cascaded component, we have to set persistent mount to true, enable the feature basically. And then we have two parameters, basically control how often the generic messages get sent on the login stream. And I'm gonna share my screen to provide a quick demo.
So I make you to the presenter now.
Please, yes, please.
Okay.
Perfect, thank you, Christian. Okay, so in my setup, I have test server running on the top left, and I have ADS cascaded from the test server. And then I have RTC connected to the ADS, and then I have a test client to drive the item request. The persistent connection is between ADS and cascaded RTC. So let me bring up my ADS, upstream ADS configuration. So the only thing I need is setting the persistent recovery time to 10 minutes. And in the RTC downstream, this is my persistent mount setting. I'm gonna disable the feature first to show you how the recovery look like. Just start up my ADS, my RTC. If I go back to my ADS, I see one mouse connected, and session type should be normal because I have persistent mouse disabled. And now my test client is requesting 50,000 items. So if I go to my RTC mon, I should be 50,000 item loading up into RTC already. And then I'm gonna simulate a disconnection between ADS and RTC. So I go to source session, and then I disconnect the channel between my cascaded RTC and upstream ADS. So if I go back to the service, I can see all items are gone. And right now it just reconnected, and you can see we slowly request all the items to rebuild the cache. So it's gonna take probably 15 or 20 seconds to do so, as we slowly rebuild the cache from scratch. And then let me queue my RTC and ADS mon and ADS. And then this time I'm gonna enable persistent mode. So if I go to my ADS mon upstream, go to the signal, I can see right now the session type say it's persistent. And the upstream ADS also auto-generated the session key to the RTC downstream. And the RTC downstream supposed to hold on to this session key and store it. And let's say the session is disconnected later. Upon reconnection, the RTC is supposed to send the same session key on the login request stream. So the upstream ADS know that, okay, this is the previous guy that disconnected, and now this guy is coming back. So this is kind of the unique key generated to cascaded component. And I'm going to simulate disconnection, but this time the mouse is persist, so we should see quicker recovery. So I go to disconnect channel, set it to true. And right now the session is gone, but you can see the mouse still persists in the upstream ADS. Right, and you can see the recovery is like a snap recovery. It came back right away. Because what we need to do is just send unsolicited refresh for the item that were out of sync. If I look at my test line, I can see 22 unsolicited refreshes because those 22 items were out of sync. So it's just like a push mechanism to recover item streams. Just to take a quick look at the session key. So you can see that initially the first connection, we provide session key to the downstream RTC, And then I simulated disconnect. And then 10 seconds later, the RTC come back and try to reconnect. So we can see the RTC re-request, then a re-request login with the same session key that it got previously. And then the upstream ADS re-accepted the persistent connection. In ADS, we also added a new memory counter. Counter. So it's how items out of sync during disconnect. These are the 22 items that were out of sync during disconnected. So you can see how many items were recovered after we connected. And just a quick note, the persistent mount can be used in conjunction with provider warm standby and other resiliency feature. Right, so you can have multiple layers of resiliency if you want to. Thank you. That's all I have. Back to Jeff.
Hi, thanks, Parvat. Thanks for this live demo. We go now forward to the slide 16 again. So we'll share the screen. So Jeff, back to you.
Yep. Thank you, Christian. Thank you, Parava. Thank you, Joe. Okay, so we're down to the last deliverable on this page. The last third quarter deliverable on this page is an enhancement for the access policy enforcement. And basically, security has become an ever-increasing concern in the cloud. And stronger methods and better standards for authentication or access to sites has been developed. So what we've done here as of the beginning of this month is we've implemented a new authentication model, basically that will reduce security token refreshes and improve persistent connections for those customers who are accessing our real-time optimized feed from RTDS. And again, there's, as more customers start connecting to real-time optimize, this is a really strong enhancement because of some issues that we've been seeing from an older method of authentication. So this authentication upgrade or enhancement is actually very timely based on the upcoming edge device migrations over to real-time optimize that James mentioned earlier in the presentation. All right, so on to the next slide, please. All right. I'm conscious of time here. Oh, let me actually say one thing. For anybody here who has any questions to any of the participants, there is a chat window here in the top of your screen. If you have any questions, please submit those, and one of us will respond to that question if we can. We're going to get to a question and answer session as well. So as I'm saying, if you have questions, please put them into the chat now. All right. So anyway, back here, we're now on fourth quarter deliverables, and because we're going to be running out of time, I'm kind of conscious that I also want to get to DACS, the DACS roadmap. So for the fourth quarter, except for Red Hat 8, which I mentioned earlier, I'm gonna skip over the rest of Q4, but I know customers have asked for Red Hat 8. I mentioned earlier we offer Red Hat 8 in this quarter, in this month rather. That was the real-time connector binaries for Red Hat 8. And now by the end of the year, we'll be offering the native binaries for both ADH and ADS with category A support as well. So the benefits, again, with Red Hat 8, it offers better manageability, improved performance, and enhanced security features. So again, something customers have asked for. Customers can start planning for this now, so they're aware of that. And Christian, if you could drop the link to the roadmap into the chat window, and then anyone who's interested can see what else is planned for Q4, and you can email me if you have any questions. All right. And then I'm going to now move over to slide 18. This is actually my last slide, but I want to hit quickly on the DACS roadmap. And again, I mentioned, we're only focused today on the large enhancements for the most recent release we did in the fourth quarter release. So you'll see we have 2 large enhancements for DACS here at the end of 2021. And again, it's the predefined off-the-shelf DACS deployment for the cloud. And we provided this same enhancement at AWS at the end of June, and now for Azure at the end of September, which is the Microsoft cloud, and then we'll offer it at Google GCP in December. And basically, this provides you this pre-packaged solution for both DACS and the real-time connector that will be supported by our global help desk. And for DACS, basically what this does, again, I mentioned it's great to have real-time data available to you in the cloud, but what this enhancement does with DACS is allows you to manage your user entitlements, which will address compliance issues that you might have, and it also help you manage your market data costs more efficiently. All right, so this wraps up my session here with the RTDS and DACS update. As again, I mentioned my emails at the beginning of the presentation. We'll get you a copy of the presentation, and reach out if you have any questions or need additional information. I know Christian has a couple more slides here he wants to cover. So thank you everybody for attending again, and I'll turn this back over to Christian. Thank you, Christian.
Thanks, Jeff. So we have now unmuted the micros. And we'll start our Q&A session for today. So let's have a look on the chat. Please unmute yourself and raise your question, please. So yes, the slides will be shared after the session. So we will send this to all participants. Yeah. Next question, please. You have also the possibility to unmute yourself now. Oh, there's Corinne. Yes. Okay. There is.
Okay. No, I think I found the unmute button. So, question: Red Hat 8 support. Jeff mentioned ADS and ADH. Will that be the same for the other components like ATS and things like that?
Yes, correct. We're working on Red Hat 8 for all the major components of RTDS.
Okay. And do you have a release target available for that?
Unless Vesna's on, who's the product manager, I'm not sure of the date, but certainly we can get back to you on that one.
I'm rather than the date, I'm thinking about which versions I can possibly put into test now.
Certainly 1.6, I'll say, Graham, and
1.6 for the ATS, and what for? I'm guessing 3.5.3 for ADS, ADH.
It'll be ADH and ADS will be 3.5.4 in December.
Okay, 3.5.4. All right, that's great. Thank you very much, Jeff.
All right, you're welcome. Thank you. Go ahead, Graham.
No, I've done. Thank you.
Okay. I see a question here about DACS tools for support for RSSL. This is something that is currently in development. We're going to port the 4 DACS tools utilities over to RSSL. It is in progress. I don't have a firm date for you now, but it's certainly something that's being worked on.
Thanks, Jeff. So any other questions? No. So my colleague already provided the server link. It will be great if you can take a few moments on that one. So we are coming now to the end. So you see here all the links we provided during the sessions. There is a link to the Refinitiv real-time distribution roadmap, the Refinitiv real-time data access control system roadmap, And also there is a link on the new on the enhancements of the latest release of ADS and ADH. So all links will be redirected to my Refinitiv. Sign in and see what's going on here. If you are interested in further academy classes, click on solution.refinitiv.com and /academy. So there are a lot of new academy classes related to RTDS, Refinitiv Real-Time Optimized, ATS, and so on. So that's all for today. So thanks to all of the team presenting and supporting this webinar. Hope you enjoyed listening. Good day, and thank you very much for your attendance.